Hello everyone, in today's video we are going to be talking about the nth order non-homogeneous ODE. In our previous video we talked about the homogeneous part of the ODE where we have to solve for the auxiliary equation and the particular solution. In today's video we are going to be talking about the non-homogeneous part of the ODE. Right, so the non-homogeneous part of the ODE is an expression that is given by the form of the ny over the x to power n plus a naught the n minus 1 y over the x to power n minus 1 plus a1 the n minus 2 y over the x to power n minus 2 to the form of a naught y any equal to f of x. So in this non-homogeneous ODE, we are actually treating each part separately. We treat the left hand side separately and then also treat the right hand side separately, and then we also move on treating both sides after treating the left hand and the right hand side. We'll come back in treating both sides. Alright, so we treat the left hand side homogeneously, and then we use several methods in treating the right hand side. Then after then we add the solution gotten from the left hand side and from the right hand side together to get our general solution. Alright, so firstly, before we solve the non-homogeneous ODE, I'm going to give some methods of solution. The methods of solution for the ODE, in this case now we treat the left hand side homogeneously, meaning that we are going to equate the left hand side to be equal to 0, meaning that this expression, we're going to express this form homogeneously. That is to say that the ny over the xn plus a naught the n minus 1 y over the x power n minus 1 plus a1 the n minus 2y over the x n minus 2 plus any equal to 0. Right, so this left hand side should be equated to 0 so that we can be able to find our complementary function, which in the other video was called the auxiliary solution. Right, so after we've done that, we are going to obtain result, that is the complementary function. We are equating the left hand side to be equal to 0 so that we can be able to find the complementary function. The complementary function, which is denoted by y subscript c or cf. Alright, so either of that, you can follow either of that. So after solving this homogeneously, which I explained in our last video, in our last class, you are going to assume solution, looking for the root. Then at the end of your solution, you should be able to get a y complementary of the form c1 exponential m1x plus c2 exponential m2x plus c3 exponential m3x as the root may be. Then secondly, after you are done solving for the left hand side, then you solve for the right hand side, which enables you find the particular integral. So after looking for the complementary solution, secondly you look for what we call the particular integral, which is represented by yp or pi. Alright, so after looking for the particular integral, which is dependent on the nature of the f of x, right, so the particular integral can be determined by the nature of the f of x in this point, which we are going to be talking about several cases where the f of x is separate. Right, so after we have looked for the particular integral, then we go further to look for what we call the general solution. General solution. Right, so how we can find the general solution is by summing up the complementary function and the particular integral. That means that y should be equal to yc plus yp. Right, so there are several methods used in solving the non-homogeneous equation. Right, there are several methods used in solving the non-homogeneous equation. These methods is as a result of finding the f of x. Right, so looking for the f of x, which is the right hand side of the non-homogeneous equation, we employ several methods so that we can be able to look for the f of x depending on the nature of f of x. Right, so we can say that some several methods like first we have the method of undetermined coefficients, method of undetermined coefficients. Undetermined coefficients. And then secondly, we have another method called the variation of parameter method. We also have another method called the operator D method. Also have another method called the Laplace transformation method. Alright, so we're going to be employing these methods in order for us to look for the y particular for f of x. Right, so in course of this video, we are going to be treating the first method, which is the method of undetermined coefficient. Alright, so the method of undetermined coefficient is the first method listed in our various methods of solving the non-homogeneous part of the ODE, more especially in looking for the particular integral. Right, so for this non-homogeneous equation, the method of undetermined coefficient, we use this method to find the f of x part, that is the right hand side of the non-homogeneous equation. Don't forget that I give an expression of the form a naught the n minus 1y over the x n minus 1 goes to the form a n y equal to f of x. Right, so in this method, we also follow the same process. Equate the left hand side to 0. Equate left hand side to 0. After equating the left hand side to 0, the right hand side, we use this method in this right hand side in order for us to obtain the solution for yp, that's the particular integral. So in this method, in obtaining the solution for particular integral, we assign solution to yp. And the solution that will be assigned to yp will be dependent on the nature of f of x here. So I'm going to give you several cases whereby the f of x changes or varies. How do you assign their particular integral? How do you assign the solution to yp? So I'm going to give some cases. So for case 1, if I have f of x to be in the form of x to the power n, I'm going to assign yp to be equal to a naught xn plus a1 x to the power n minus 1 plus a2 x to the power n minus 2, as the case may be. Right, so this a naught, a1 and a2 are constants, so you can equally use the constant of your choice. Right, so secondly, we have f of x of the form sin x or cos x, or the summation of both sin x with cos x plus sin x. What kind of solution am I to assign to yp? I'm to assign yp to be equal to a naught cos x plus a1 sin x. If I have f of x in this point to be equal to exponential lambda x, so in this case, what kind of solution am I supposed to assign to yp? I will assign yp in this form to be equal to a exponential lambda x, where a and lambda are all constants. Alright, so I'm going to take a few examples in order for me to illustrate the method of undetermined coefficient so that we can be able to understand what I'm talking about here. And so we are going to take an example. And so we are going to be taking an example in order for us to illustrate further what this method is all about. Right, so we have to solve the differential equation using the method of undetermined coefficients. Alright, so this is a past question, number 1B of the 2022 academic section of Rivers State University. So we have d square y over dx square minus 6dy over dx plus 9y equal to x cubed. So in this case, just like I said earlier, we are going to equate the left hand side to be equal to 0 so that we can be able to find the complementary function, which is the auxiliary solution of the equation. So I'm going to equate left hand side equal to 0. Means that the square y here over the x squared minus 6 dy dx plus 9y should be equal to 0. Alright, so in our previous video I talked about how to solve the homogeneous part in this form. So firstly, we are going to assign a solution to y, which I said that we assign y to be equal to exponential mx. And then because this is to power 2, we are going to differentiate this twice. We are going to differentiate y twice to get dy over dx here to be equal to m exponential mx. And then we'll get the square y over the x squared here to be equal to m squared exponential mx. So at this point, we're going to substitute the values of dy and the square y to this expression so that we can be able to obtain the roots and then get our complementary function. So the square y here is m squared exponential mx minus 6 dy dx here is m exponential mx plus 9y here is exponential mx all equal to 0. So if I factor out exponential mx here, I'm going to have m squared minus 6m plus 9 all exponential mx equal to 0. So provided exponential mx in this point is not equal to 0, we are going to solve the quadratic point in order for us to obtain the roots to get our complementary function. So m squared in this form will be m squared minus 6m plus 9 should be equal to 0. So if I solve this quadratically, I'm going to obtain a root. Minus 3 and minus 3 satisfies this equation because minus 3 times minus 3 gives me plus 9. Minus 3 minus 3 gives me minus 6. So this will be minus m minus 3 and m minus 3 equal to 0. So it means that my m1 in this case is equal to 3, while my m2 here is equal to 3. So this also satisfies another case in our previous video, which I told you that for a real and repeated root, we have a form of writing the auxiliary solution, which is a complementary function. So we've gotten our roots to be repeated. That's m1 3 and m2 also 3. So our complementary function, which is yc here, will be equal to For a repeated root, I told you that C1 for a repeated root equal to C1 exponential M1x, because we have only two roots. It should be plus C1x exponential M2x. So y complementary will be equal to C1 exponential M1 becomes 3, then plus C2 x exponential M2 becomes 3. So this is our complementary function. So we'll go further to look for the particular integral. Which is yp. Notice from the equation given, I'm going to write down, let me just go back to this question. Right, so notice from the question given in this point, I told you that this is our f of x. From this point, comparing this and this, you see that f of x here is equal to x to the power 3. So I'm going to solve. So provided that f of x is equal to x to the power 3, right? So since f of x is equal to x to the power 3, we are going to assume a solution to yp. And I gave some cases for different f of x, right? So if the f of x, I said that if the f of x is equal to x to the power n, we assign this particular root to our yp, provided that n here becomes any number. It can be 2, it can be 3, it can be anything, any number, right? So since we are giving our f of x to be this, we are going to be assigning our yp to be this. So it means that my yp, I'm going to assign a naught x to the power 3 plus a1 x to the power 3 minus 1 here becomes 2 plus a2 2 minus 1 here becomes 1, then plus a3. Alright, I've succeeded in assigning a solution to yp. So next up here, I'm going to differentiate yp twice, because if you check the differential equation given the question, we have our highest power here to be 2. So it means that I'm going to differentiate yp twice. So in differentiating yp, I'm going to be having y prime of p to be equal to, if I differentiate this, I will have 3a naught x to the power 2 plus 2a1 x, then plus a2. Right, so if I differentiate this again, I will have y prime prime of p to be equal to, this becomes 6a naught x, then plus 2a1. Right, so I'm going to substitute. Let's record the question. Recall the equation. The equation given was the square y over the x squared minus 6 dy dx plus 9y equal to x cubed. Right, so this is the equation given. To recall this equation, so since we've recalled the equation, to be this, we are going to substitute the square y over dx to this point, and then substitute dy dx to this point, and then substitute our y to this point, and equate it to f of x, which is this. So my d square y dx squared is this point, which is 6a naught x plus 2a1. So this point becomes 6a naught x plus 2a1. Right, so that's for this. I have minus 6 into dy dx, which is this, becomes 3a naught x squared plus 2a1 x plus a2. Right, so my yp, which is my y, becomes plus 9 into the whole of this. I have a naught x to the power 3 plus a1 x to the power 2 plus a2x plus a3, all equal to x to the power 3. So I'm going to open up the brackets and multiplying minus 6 throughout the bracket and multiplying 9 throughout the bracket. So I will be able to obtain 6a naught x plus so I'm going to be having 2a1 minus 6 times 3 here becomes 18a naught x squared minus 6 times 2 becomes minus 12a1x minus 6 times 1 becomes minus 6a2. We have plus 9a naught x cubed. We have plus 9a1 x squared. We have plus 9a2x plus 9a3, which all is equal to x cubed. So at this point, we are going to be collecting like terms. So if we collect like terms, we are going to be having 9a naught x cubed. We'll pick out all the x squares together. We'll be obtaining minus 18a naught. I have plus 9 plus 9a1 x squared. That's for this. Then I also have for x 6a naught x. I have minus 12a1 x. I have plus 9a2 x. Then I also have plus plus 2a1. I have minus 6a2. I also have plus 9a3, all equal to x cubed. So after I've done this, I'm going to be comparing coefficients. So if I compare coefficients, I'm going to compare the left hand side to the right hand side. So if you check very well here, I have x cubed here. So I'm going to have a naught x cubed equal to, for the left hand side, I can find x cubed at the left hand side and also find x cubed at the right hand side. I have minus is 18x squared. I have minus 18 a naught x squared. I have plus 9a1 x squared equal to, so at the left hand side I can find x squared but cannot find x squared at the right hand side. So this will be equal to 0. I also have 6a naught x minus 12a1 x plus 9a2x equal to 0, because I can't find x to the power 1 here. And then lastly I have 2 so for the last one I have 2a1 minus 6a2 then plus 9a3 all equal to 0. So I can call this equation 1, call this equation 2, call this equation 3, and then I can call this equation 4. So I can call this equation 4. So from equation 1, if I divide both sides by x cubed, I'm going to have a naught equal to 1. Right, so if I divide both sides from equation 1, which is this one here, if I divide both sides by x cubed, I will have a naught equal to 1. So 9a naught equal to 1. So I can call this equation 5. So here, if I divide both sides, because the common term here is x squared, so if I divide both sides here, if I divide the left and the right hand side by x squared, I will obtain minus 18 a0 plus 9a1 equal to 0. And then same as here, I can call this equation 6. Then for this, I'm going to divide both sides by x to get 6a0 minus 12a1 plus 9a2 equal to 0. I'll call this equation 7. And then lastly, I have 2a1 minus 6a2 plus 9a3 equal to 0. Call this equation 8. So from equation 1, right, so from equation 5, I can obtain my a0 by dividing both sides by 9. So if I divide both sides by 9, I'm going to be having a0 equal to 1 over 9. Alright, so then after, I'm going to substitute the value of a0 to equation 6. So substituting a0 to equation 6 for us to obtain a1. So I'm going to be having minus 18 to this equation. A0 becomes 1 over 9. I have plus 9a1 equal to 0. So minus 18 over 9 plus 9a1 equal to 0. Because minus 18 times 1 gives minus 18, and I still have over 9. Alright, so I have minus 18 over 9, which is going to give me minus 2. And I have plus 9a1 equal to 0. So if I move minus 2 across equal to sign, I have 9a1 equal to 2. Therefore, my a1 at this point becomes 2 over 9. I'm going to substitute the value of a0 and a1 to equation 7 for me to obtain a2. So substitute a0 and a1 to equation 7. So if I substitute that to equation 7 as this equation, I'll be having 6a0, and a0 here becomes 1 over 9. Then I have minus 12a1. a1 becomes 2 over 9. This is 2 over 9. Then I have plus 9a2 equal to 0. So 6 times 1 gives me 6. I have over 9 minus 12 times 2 gives me 24. I have over 9. Then plus 9a2 equal to 0. So if 3 goes into this point, it gives me 2. If 3 goes into 9, it gives me 3. So 2 over 3 minus, I have 24. If 3 goes into 24, I have 8. If 3 goes into 9, I have 3. I have plus 9a2 equal to 0. So I'm going to cross 2 over 3 and minus 8 over 3 cross equal to sign, so that we'll obtain 9a2 equal to 8 over 3 minus 2 over 3. Right? It means that my 9a2 here becomes 8 over 2, 8 minus 3 over 3, 8 minus 2 over 3. So I'm going to obtain 9a2 here to be equal to 8 minus 2 here becomes 6. So 6 over 3 is still going to give us 9a2 equal to 6 divided by 3 is 2. So my a2 here becomes 2 over 9. Right, so the last thing to obtain there is a3. So we are going to substitute the value of a1, a2 into equation 7. So we are going to substitute the value of a1, a2 into this equation, that is equation 8. And so if we do that, we are going to be obtaining 2 into our A1 is 2 over 9. And I have minus 6 into our A2 is also 2 over 9. Then I have plus 9A3 equal to 0. Right, so these are A2 is 2 over 9. And these are A1 2 over 9. So we are going to be obtaining 2 times 2 from here is 4. I have 4 over 9 minus 6 times 2 here is 12. I have 12 over 9. I have plus 9A3 equal to 0. So I'm going to cross 4 over 9 and minus 12 over 9, cross the equal to sign for me to obtain A3 equal to 12 over 9 minus 4 over 9. So 9A3 becomes, if I take the LCM here is 9. This cancels this, I'm left with 12. Minus this cancels this, I'm left with 4. Right, so 9A3 here becomes 12 minus 4 here gives me 8. So I have 8 over 9. So if I cross multiply in order to make A3 subject of the formula, I'm going to have A3 equal to 8 over 9 times 9. So our A3 here becomes 8 over 81. Right, so that becomes the value of our A3. So for A0, I had 1 over 9. For A2, I had 2 over 9. For A1, I had 2 over 9. A2, I had 2 over 9. And A3, I also had 2. A2, I had 2 over 9. And then A3, I had 8 over 81. So I'm going to plug the values of this constant to the assumed solution of YP. So we can recall that YP was given by, this. So these are YP. So we are going to plug in A0, A1, A2, and A3 to this assumed solution. So we can be able to obtain our particular integral. So I have my YP to be equal to A0 x to the power 3 plus A1 x to the power 2 plus A2 x to the power 1 plus A3. So YP here becomes equal to, my A0 is 1 over 9 half x3 plus A1 gives 2 over 9 x squared plus A2 also gives 2 over 9 x, then plus A3 gives 8 over 81. So I can factorize this form and factorize this expression because 1 over 9 is common. So I can say 1 over 9 into, this becomes x cubed plus 2x squared, and this becomes plus 2x, then plus 8 over 9. Right, so we can say that our particular integral, therefore our particular integral YP is equal to 1 over 9 x cubed plus 2x squared plus 2x plus 8 over 9. So these are particular integral. And then next up, we are going to look for the general solution. So the general solution y is expressed in the form of y equal to y complementary plus y particular. So we are going to sum up the complementary solution and the particular solution to obtain our general solution. So our general solution y becomes equal to a complementary solution we got was so the complementary function we obtained was this. So we are going to be having the complementary function, which is this. We have c1 exponential 3x plus c2 x exponential 3x. Right, so plus we have our y particular. Right, so we have our y particular to be this expression. So this becomes plus 1 over 9 into x cubed plus 2x squared plus 2x plus 8 over 9. Alright, so if I move further of this, I'm going to have y equal to c1 exponential 3x plus c2 x exponential 3x plus 1 over 9 into x cubed plus 2x squared plus 2x plus 8 over 9 as the solution to the problem. Right, so in the next video we are going to be talking about other parts or other methods of determining the non-homogeneous equation. So this is the problem solution of the non-homogeneous ODE by undetermined coefficients. Thank you.